large steel pipe is ready to be lifted. The crane is available. The operator is experienced. The lifting accessories appear to be in good condition. Everything looks ready, but do we know the actual weight of the load? Do we know the lifting radius? Is the crane configuration suitable? Has the rigging arrangements been checked? And does everyone understand exactly how this lift will be performed? A lifting operation can look routine and still contain the conditions for a serious incident. Safe lifting begins long before the load leaves the ground. In part 1, we will cover the major hazards of lifting operations, responsibilities of lifting team, lifting planning, load weight and center of gravity, crane capacity and lifting radius, crane setup, ground condition, lifting accessories, rigging arrangements, exclusion zones, and pre-lift briefing. By the end of this video, we will have the load properly prepared and ready for lifting, but we won't lift it yet. So here's a question. What is lifting operations? A lifting operation involves raising, lowering, or moving load using lifting equipment. But safe lifting is not simply about whether the crane can pick up the load. The crane, lifting accessories, load characteristics, ground conditions, people, environment, communication, and lifting method must all work together as one controlled system. Lifting operation can expose workers to drop loads, swinging or rotating loads, equipment instability, rigging failure, pinch and crush points, unexpected load movement, and contact with the surrounding structures or equipment. One of the most serious hazards is the line of fire, the area where a person could be struck, trapped, crushed, or caught if the load or equipment moves unexpectedly. A safe lift required clearly defined responsibilities. Depending on the lifting operation and applicable procedures, the team may include the crane operator, qualified rigger, a designated signal person, a lift supervisor, and other personnel required to control the activity. Everyone must understand their roles before the lift begins. Most importantly, the crane operator should receive normal operating signal from the designated signal person rather than conflicting instructions from several people. Before selecting the crane rigging arrangements, understand the load. Confirm its weight from reliable information rather than guessing. Consider its dimensions, shape, lifting points, center of gravity, surface conditions, and any loose or unsecure components. If the center of gravity is not properly considered, the load may tilt, rotate, or become unstable when it is lifted. The center of gravity is the point around which the weight of the load is balanced. For a stable lift, the lifting arrangement must control the load in relation to its center of gravity. If the lifting points or sling arrangements are incorrect, the load may tilt as soon as the weight is transferred to the crane. Never wait until the load is high in the air just to discover that it is unbalanced. Crane capacity is not determined by the number written on the side of the crane. The allowable load depends on the crane configuration and operating conditions, including factors such as lifting radius, boom configuration, and the manufacturer's load chart. As the operating radius changes, the available capacity can also be changed. The crane must therefore be selected and configured for the actual lift, not simply because it has lifted a similar load before. A crane can only perform safely when it is properly set up. Evaluate the ground conditions, level and stability of the setup area, underground hazards where applicable, nearby excavations, structures, traffic, and other conditions that could affect stability or operation. For cranes using outriggers, the outriggers and supporting system must be configured according to the manufacturer's requirements and the lifting plan. Before operations, the crane must receive the inspections required by applicable procedures, manufacturers, and regulatory requirements. The operator should verify that the crane is in suitable operating condition and that required safety and operation systems are functioning. Any defect that could affect the safe operation must be addressed before lifting begins. The lifting accessories must be suitable for the load and planned rigging arrangements. Slings, shackles, hooks, spreader beams, and other components must have adequate rated capacity and to be compatible with each other. The capacity can also be affected by how they are used, including sling configuration and load conditions. Never select rigging simply because it physically fits the load. Every lifting accessory must be inspected as required before use. Look for damage, deformation, excessive wear, broken wires, cuts, heat or chemical damage, damaged stitching, cracks, distorted fittings, missing identifications, or any other condition that could affect safe use. Defective equipment must be removed from the service in accordance with the applicable requirements. Rigging must keep the load stable and distribute the forces through suitable lifting points and components. Consider sling arrangements, sling angles, load balance, hook engagements, protection from sharp edges, and possibility of the load shifting during movements. Rigging should be installed by component personnel who understand how the configuration affects the forces in the system. Slinging angles matters because changing the angle, changing the tension in the sling legs. As the sling legs become flatter, the force in each sling increase. This means that sling capacity cannot be assessed from the load weight alone. The complete rigging geometry and manufacturer's rated information must be considered when selecting the arrangements. Before lifting begins, establish and control the lifting area. Keep unauthorized personnel away from the crane operating zone, suspended load area, intended load path, and landing locations. Workers involved in the lift must also position themselves so that the unexpected movement cannot trap them between the load and another object. Before the crane moves the load, everyone should know where it is going. Check the complete load path for structures, equipment, overhead hazards, workers, vehicles, and other obstructions. The landing area must also be prepared so the load can be placed safely without workers having to improvise while the load is suspended. Communication must be agreed before lifting begins. Identify the designated signal person and confirm the communication method. Where radios are used, message should be clear and acknowledged. If communication is lost or the operator does not understand the signal, movement should stop until communication is restored. Any person who identifies an immediate danger must be able to give the emergency stop signal. Before the load leaves the ground, bring the lifting team together. Review the lift sequence, individual responsibilities, crane position, rigging arrangements, load path, exclusion zones, communication method, landing area, environmental conditions, and what will cause the job to stop. If someone does not understand the plan, resolve it before lifting begins. Now perform final reading check. Is the correct crane position and configured for the lift? Is the load weight known? Is the rigging suitable and correctly installed? Are the lifting accessories inspected? Is exclusion zone established? Is the load path clear? Is the landing area ready? And does everyone understand communication method? Only when these conditions are confirmed should the lifting operation proceed. So the preparation is now complete. The crane has been selected and inspected. The load is understood. The rigging arrangement has been checked. The lifting area is controlled and the team understands the plans. But the load has not yet been moved. In part number 2, we will begin with the trial lift and cover communication, suspended load control, line of fire management, tag lines, changing conditions, safe landing, common lifting mistakes, and how to complete the operation safely.